Okay, we have here today another interesting integral from the MIT integration bee. This one's 2012, problem number 3. We have the integral of 1 over 1 plus square root x minus x squared dx. Okay, at first I was thinking maybe there was a way to do a trig substitution, but it's not really in the form we like, and especially here inside the square root. But what we can do is I can factor an x out of that. I can factor that just like x equal to 1 minus x. And then if I split this up, we're going to have a square root of x and a square root of 1 minus x. Then what I'm going to do is I'm going to bring this square root of x into the numerator. I'm going to write it as x to the minus 1/2. Then we'll just have this piece, the square root of 1 minus x and 1 plus square root x. And then from here, I'm thinking about a u substitution. Now we have actually a square root of x here, a square root of x here, and then we can create one right here. If I write x as, we can write x as square root of x squared. Then what I can do is we can make a u substitution for square root of x. I'll take my derivative. We could solve for x, but I think we'll just do it this way. So taking the derivative here, we're going to have 1/2 x to the minus 1/2. Just recognizing our numerator is similar to that, but I can just multiply by 1/2 so that we have exactly our du right here. I'll multiply by 2 out front, so we're not changing the expression. And then we'll just go ahead with this substitution. So we'll have that du in the numerator here. This becomes a u, so we have 1 plus u here, and then this thing is going to become, what is this thing going to become? This thing's going to be 1 minus u squared. And now this part right here is looking exactly like what we like for a trig substitution. I'm not sure about this, but let's just go for it, and we'll do a trig substitution. I'll substitute for u. I'm going to call my u equal to sine of t. And of course, because we're doing two substitutions, you could do this all in one, but it doesn't seem very intuitive in this case. So we'll do two substitutions. So my u is going to be sine of t. I'll take my derivative. Du is going to be cosine of t dt. So I'll have my cosine of t dt here in the numerator. Let's see about the denominator. So this is going to be 1 plus sine t here. This is going to be 1 minus sine squared t inside the square root. But 1 minus sine squared t is the same thing as cosine squared t. But because the cosine squared t is inside the square root, this is just going to be cosine t. I'm just going to cancel this with this. And then I'm just going to rewrite it so it's not such a mess. We have our 2 out front, and now we're just integrating 1 over 1 plus sine of t. And I actually just did a video not very long ago with that exact same integral. And I don't know if you saw that one, but we're going to do the same thing. I'm going to multiply the conjugate by the numerator and denominator. Now that caused problems in the other video, but it's actually not a problem here. In this original integral, we have like a really restricted domain. You notice like you can't have, x can't be 1, x can't be negative because of that. So because of the restrictions here, we're not going to have any problem here. Okay, continuing from where I left off, we just need to multiply this in here to simplify this. So let's see what we have. We're just going to have 1 minus sine t in the numerator. And here when I multiply the denominator together, I'm going to actually have 1 minus sine squared t, but of course that is going to be cosine squared t. So what I'm going to do is actually split this into two integrals. We'll divide 1 by cosine squared t, and for the first one we're going to have just secant squared t. And then for the second one, sine over cosine is tan with another cosine, so we end up with tan times secant here for the second integral. And that's nice because both these are easy integrals. So for the first one, the integral of secant squared t is going to be just tan t. I think I'm going to actually factor this 2 back out. I don't know why I multiplied it together. And then the integral of tan t secant t, well, that's just going to be secant t. And then so all we have left to do to finish this off is just to back substitute. And what I'm going to do is I'm going to draw my triangle using this right here. So we're going to have our triangle. The angle is going to be t. And yeah, that's not the best right there. But so if our angle is t on sine, we want opposite over hypotenuse. I can write this as u over 1. So I can write a u here and a 1 here. We can use Pythagorean theorem to find our third side. That's going to be just 1 minus u squared. And then I just need a value for tangent and secant. Tangent, opposite over adjacent. So our tan t, let's just pencil it in over here in marker, is going to be u over square root of 1 minus u squared. Secant t is going to be hypotenuse over adjacent. So our secant t is going to be what? 1 over square root of 1 minus u squared. But rather than putting it back into u, we want to get it back to x. So each of these u values is square root of x. So I can actually get it all the way to x here. So we can have over here square root of x. And this one, square root of x squared, this is going to give me a 1 minus x here. And then for secant, I don't really have room there, so let's put it over here. This is going to be the same denominator, so it's just going to be square root of 1 minus x. So now we'll take these two values and plug it back in for tan and secant. So let's see what we have. We have our tan value, square root of x, square root of 1 minus x. And then our secant is going to be just this thing. But then we have a common denominator here, so I can just put these things together. And so I think for our final solution, I'll write it like this. We'll write 2 square root of x minus 1 over square root of 1 minus x plus c, and that's it. Okay, pretty good problem. So kind of some straightforward steps, but I still like that one, so we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.